Hey everyone, and welcome back to this series of electrical A6 power systems and machines exam. And this is a recent question about per unit calculations. Now, usually the per unit calculations is an integral part of a short circuit calculation question. So first you need to find the per unit and then you do the calculations. But here in this question, no, it is exclusive question for only for the per unit, which is usually asked more in B7 rather than asked in A6. And this is why I said recently that there is an overlap between A6 and A1. I have shown to you some simple circuit questions for power calculations that sometimes asked in A1. And there is a little bit of overlap with B7 as well. So let's see the question. It says here, draw a reactance diagram. So we want to draw the reactance diagram of this system. So this is called single line diagram. So I want to draw the reactance diagram. And usually we draw the reactance diagram in per unit, but the per unit has to be using one common base system. Starting from the generator, it says this is a 13.8 kilovolt generator and it is 10 MVA. And it has a sub-transient of 15%. So this is the sub-transient reactance. The generator is supplying power to two motors. We have two motors here. Let me call this is motor 1 and motor 2. Okay. And basically these motors are rated same rating, 10 MVA, 13.8 kilovolt, and 10% the per unit reactance. Now, this reactance and this reactance are basically calculated, it's a percentage based on the generator or the motor ratings. But as you can see here, the ratings of the generator and the rating of the motor are exactly the same. So it's meaning that they are using the same base system. And the series reactance of the transmission line here is 80 ohm. So here Z or X line is given in ohms, not in per unit. So this needs to be converted. Now you notice here we have two transformers, XT1 and XT2. The question has ignored their values. Okay, so we need to assume them to draw the full reactance diagram. We cannot ignore the transformers. Transformers, they need to be included. Okay, so basically we need to assume, I think this is missing from the question. So I will assume that these two transformers, XT1 and XT2 are exactly the same. I will assume their rating same power, 10 MVA. Now XT1 is a step-up transformer, 13.8 by 138 kV. Okay, and it has reactance, let's say 10%. XT2, 10 MVA, 10%, but it is stepped down 138 by 13.8 kV because as we know that this is 13.8, so the transformer has to bring the voltage, this voltage, which is the transmission line voltage, to the 13.8 kV. Now you could assume anything else. It could be 13.8 by 220 kV or 130 kV. You can assume anything, but it's not really given in the question. Okay, now to solve this question, we need to identify the zones, and the zones are identified by the transformer. So basically we have here the generator connected to the first transformer. Okay. And then, so this is called point A. I will use the same. This is point B. Then we have here the transmission line, then point C. Then we have another transformer here. And then basically we have here, I will call this is M1 and M2. And because we are basically finding the positive sequence reactance, the grounding here, it doesn't make any difference if it is Y connected or through grounded or not grounded. That has no influence on the reactance diagram. This is important if we have to draw the negative and the zero sequence, then these things, especially in the zero sequence, will have an impact. Now we have to identify the zone. So the transformer will split the zones here. So we have here zone 1, zone 2, and zone 3. And then we need to find the S space for everything. So S space here, I will select the generator rating 10 MVA. And this would be the same everywhere, 10 MVA and 10 MVA. Now I selected the base that is matching the rating of the generator, which is usually the case. And then so this is S space. Then V base, again, I will use the voltage of the generator, which is the 13.8 kilovolt. Okay. Now, V base here would be the secondary of the transformer, which is the 138 kilovolt. And here it would be the 13.8, the secondary of the other transformer. So this is the S base and the V base in both. Now here, your X, I don't need XG is equal to 0.15 per unit or 15%. So I don't need really to do anything here. I will just keep it as it is because the rating of the generator and the S base, V base are matching. So it's exactly the same. For the transformers, I will basically, this is the transformer. So the transformer, your XT1 will be also the 0.1 per unit. And the reason for that, because also the transformer rating is matching basically the base system. Now for the transformer, we have a primary and secondary voltage. You can use either. Now, the thing that we need to change is basically Z line. So your Z line, or X line to be more specific, is equal to X in ohms times S base over V base square. So it's equal to 80. S space in MVA, which is 10, divide VB in KV, which is 138 square. And this will give you 0.042 or 4.2%. Now, this transformer is identical to this, so this will become XT2 equal to 0.1 per unit. And the motor XM1 equal to XM2, and this is basically equal to the 0.1 per unit. So we found all the per unit values. Now let's go and draw the reactance diagram. So we start with the generator. The model of the generator is an EMF. So this is your, call it EG. And then you have XG, which is, we already calculated, equal to 0.15 per unit. So this is equal to 0.15, everything in per unit. Now this is point A. Then we have the transformer, XT1, which we calculated as basically here, XT1 is equal to 0.1 per unit. Then we have point B. Then we have X line, which we just calculate that as 4.2%, or this is 0.042, 0.042. And then have point C. Then we have XT2, which is identical to the XT1. And then here we have I numbered M1. So this is XM1, XM2. This is will have an EM2, internal EMF, and this is EM1. So this with this grounded and connected to the generator. So this is what we call the reactance diagram, and it's in per unit, and it is in one common base system.